Welcome students to the Chapter 10 Part 2 video lecture notes. We're going to start today with valence bond theory and probably break up this video into several subsections. So let's start off with valence bond theory, and then I'll post some different videos that are shorter about the remainder of the topics. So with valence bond theory, what this says is that electrons, the valence electrons, are in orbitals, the orbitals overlap, and that's what forms a bond. Because remember, when we were talking about Lewis structures, we saw that we could draw something like the H2 molecule like this, right? So this was the Lewis structure for the H2 molecule. And what we said was this pair of electrons between those atoms are shared, and they are the valence electrons from each hydrogen that are being shared. And so what happens is those electrons are coming from the hydrogen atoms. And so imagine you have a hydrogen atom with a 1s orbital, and it has its 1 electron in it. And then you have another hydrogen atom also with a 1s orbital with 1 electron in it. And so when these two atoms come together, we draw the sharing of those electrons as the bond between the hydrogens. And what's happening is that the 1s orbital on one hydrogen atom and the 1s orbital of the other hydrogen atom overlap like a little Venn diagram. And this part here, that overlap, that's your bond. And so the electrons can really be, anywhere in this area or this area. And technically they can be even further away from that. But when those two orbitals overlap, that's what's causing your bond. Now we can have more complex examples, which we'll show you here with the Hcl molecule. So with the Hcl molecule, in our Lewis structure chapter, we drew the Hcl molecule like this. And remember that your hydrogen has 1 valence electron, and its 1 valence electron is in the 1s orbital. And then all of a sudden, things start to get super complicated with that chlorine, because then you're like, wait a moment, how do I know which orbital is overlapping with the hydrogen? Because in your valence electrons for chlorine, you have some in the S and some in the P. And so then you look at it and you say, how do I know if an s orbital or a p orbital is overlapping? And so all of a sudden, as we move from hydrogen to anything bigger, it becomes a lot more complex. So let's pretend that it's a p orbital. So if it's a p orbital that's overlapping, p orbitals have that dumbbell shape, right? S had the spherical shape, p orbitals have the dumbbell shape. And when you form this bond is an overlap of 2 electrons. So really there's only 1 electron coming from the hydrogen and 1 electron coming from the fluorine. And we'll call this a p orbital. And when those overlap, you get that sharing. And that sharing is the bond. And so we got your s orbital overlapping with the p orbital. And again, this overlap is the bond. And so what you might have figured out is that this explanation that we just went through doesn't help us understand where the lone pairs are. And also, how do you know if you're expecting an s or a p orbital to do this overlapping? And really, for more than just those two things or those two reasons, this valence bond theory just completely falls apart when it's any molecule that's really bigger than hydrogen, for the most part. And so, if you really want to know why valence bond theory doesn't work, Khan Academy has, oh gosh, is it CAHN or CH Khan or Khan? I feel like that could go either way. Let's do that. Okay, that's my bet. So, Khan Academy, if you Google search his sp3 hybridization video, he goes into great detail in a 17-minute long video as to why valence bond theory doesn't work. So instead of doing that, because even though I care about why, you might not care about why, let's really quick talk about what happened. When they found out that valence bond theory didn't work, of course, what you have to do is you have to start changing your theory. And so we changed to hybrid orbitals. Hybrid orbitals are just, oops, sorry about that, are just a blend of orbitals. So when we started talking about those shapes, the linear, the trigonal planar, the tetrahedral, and so on, we know those shapes to be true. And so what we needed was a new set of orbitals that helped describe those shapes and a new idea of how those shapes came about. And so those blended orbitals, that was it. And when you start thinking about how that blending happens, remember that your original orbitals are just wave functions. So that means they're math. And so you can take two math equations and average them, even if they're really complex, and we don't do it in this class because it takes way more than we're capable of. So when we talk about blending is really taking a mathematical average of the wave functions. And so what happens, just like, as when you look at a child and the child has both components or characteristics of each of the parents, where, maybe the kid has blonde hair like the biological dad and brown eyes like the biological mom. So what ends up happening is then your orbitals have a similar situation. Your orbitals take on the characteristics of the parent orbitals. So when you start blending orbitals, maybe we blend an s and a p orbital together and we get something that's called an sp orbital. So I want to stop here and I want to make a different video that's just focused on hybrid orbitals. So I'm going to go ahead and sign out and make a second video for you about hybrid orbitals in more detail. Thank you for your attention. I'll see you in the hybrid orbital video.